finally, we need to look at the second derivative to discuss our concavity point of inflection. Okay. So up to this point, we have incorporated our, where's my pen? We've done our roots, asymptotes, critical values, critical points. We've done positive, negative, increasing, decreasing. Just left with points of inflection, concave up and concave down. So to look at that, that is the second derivative. So f double prime of x. We're calling it the derivative was 3 over 2 x to the 1/2 minus 1 over 2 x to the minus 1/2. The second derivative is 3 over 4 x to the minus 1/2 plus 1 over 4 x to the minus 3/2, which equals 3 over 4 x to the 3/2 times x minus 1/3. So f double prime, sorry, x plus 1/3. So f double prime of x here, we might be tempted to say it equals 0. Where does it equal 0 and where is f double prime x? Does not exist. Well, we might be tempted to say at x equals minus 1/3. But here we have it does not exist at x equals 0 and x less than 0 by domain restriction. Okay? And this 1/3, we might be like, oh, we have to check your domain restriction whether or not it's a point there. Well, it's not necessarily a point there, but it's still a root of the numerator. And by just checking the domain, I can determine whether or not it's a possible point of inflection. And it's not in the domain, so it's not a point of inflection. There's no harm in finding the roots of the numerator. People get really anxious about, if it's not in the domain, should I even talk about it? Feel free to talk about it. But just be clear to reference it's not in the domain. So as minus 1/3 is not in the domain, it is not a possible point of inflection. So it's not a possible point of inflection. And as 0 is not within the domain, it is also not a possible point of inflection. But I'm still going to create a sign chart to see what the inflection is. So I have this 1/3 or minus 1/3, 0. I have the parts. I have 3 over 4. I have x to the 3/2, and I have x plus 1/3. Well, 3 over 4 is positive everywhere. X to the 3/2 is positive when greater than 0 and undefined when less than 0. And x plus 1/3 is positive until minus 1/3 where it becomes negative. Multiplying the signs, I get positive, does not exist, does not exist. Here it does not exist. Here still doesn't exist because I'm not defined there. And now extending this chart, we can see that we are concave up. So f of x is concave up for all x in 0 to infinity. F of x is never concave down. And there are no points of inflection. And finally, we need to remember to update our graph. So by pulling all of this stuff together, we take our graph, we have what we had before, Now we have the horizontal and we're concave up everywhere. And this is our curve sketch.